Okay, so this is the paper about the effects of polls and beliefs on the participation of voters. So this is a joint work with Liat Yarif, Jacob Guiri, and Julian Romero. So let me start with a few common features of many collective decision-making processes, in particular elections. There is often an uncertainty about what's the majority preferred alternative. Even though this uncertainty exists, there's also a lot of communication that goes on before the elections. So if we're thinking about elections, there's a lot of polls that people do before the actual elections. There are media reports and many other sorts of information. It turns out that if you look across many elections, the toss-up elections are less common than the landslide elections. There's a recent study by Mulligan and Hunter from 2002 that document that in United States elections, only 1 out of 100,000 voters mattered in the sense that it was pivotal, and in the state election, it's 1 of 15,000 votes. Even though there is mostly landslide elections in this world, or in our world for now, many people decide to go to polls and vote. In the United States, more than 50% goes to vote in the elections. And interestingly, many people vote for the perceived landslide winner. If you look at the just 1 year American National Election Study from 2008 and do a simple tabulation, we find that about 70% of those people who predict a large win of their own preferred alternative reported that they're going to go vote. There's also an interesting study from Brazil that documents that about 13% of people agree with the statement, "I vote for the probable winner in the elections." So what we're going to do in this paper, we're going to conduct a series of laboratory experiments to gain some insights and to understand or try to understand what makes voters vote, what makes voters turn out. In particular, we're going to be interested in exploring the effect of the information in the form of the polls and the beliefs. Our second goal is to understand the welfare effects of polls. Are they good? Are they socially bad? And stuff like that. And finally, we're going to observe how individuals respond to polls. Why experiments? So since this is the first experimental, almost, paper here, I can say a few words about that. First of all, experiments in this particular set of questions are useful because it allows us to control for preferences and to study the outcomes for the wide range of preferences. It also allows us to track the individual behavior, which might be hard to get from the field data. So we're going to observe the preferences, we're going to induce the preferences of voters, we're going to observe their voting behavior, and we're also going to elicit their beliefs regarding the election outcomes. The elicitation of beliefs is a very important thing because it provides us the direct test of the pivotal voter model, which is the underlying model used for the theoretical results on the pre-election polls. And finally, it seems like a fairly inexpensive way to study effects of polls and the effects of the different types of information. So there is a lot of literature. There are 2 types of literature that our paper is most relevant to. The first set of papers talk about the pivotal voter model with costly participation. And there is a lot of theory work, starting with the Palfrey-Rosenthal paper from 1983. And there are also a few experimental papers that study some variations of this model. And the second set of literature is the literature on polls. So I'm going to skip the mentioning all these papers right now, but I'm going to come back to the results in the other experimental papers when I'll present our results and compare them to these papers. Even though I didn't tell you what other papers did, let me tell you what we do differently from other literature. First of all, we elicit subjects' beliefs. And again, we do that in order to provide the direct test of pivotal voter model. It is quite hard to get from the field, and this we see as an advantage of doing the experiments on this topic. Second of all, we're going to inspect the behavior, how do people report their intentions in polls, and how do they respond to the information from the polls. There are many field studies that address similar questions. The important thing is that in the field data, it's quite hard to disentangle whether polls affect preferences or whether they affect voting behavior. In the experiments, we induce preferences, so we don't have this problem. We observe the direct effect of the polls on the participation rates. And finally, we're going to keep the uncertainty of a majority preferred alternative in all the treatments that we're going to run, and we think that's the circumstance in which elections are mostly interesting. Okay, so let me tell you a little bit about the structure. I'm going to start with the theoretical setup. I'm going to describe the experiment in details, and then I'm going to show you the results. So the setup is based on the model of Goiri and Jens Grosser from 2007, and we're going to implement precisely this setup in the experiment. So there's going to be n agents who needs to collectively choose one of the two alternatives, red or blue. Their preferences are as follows. There are two states of the world. Both of them are equally likely. The state of the world is either a blue jar or a red jar. I'm going to call the blue jar state of the world 0 and the red jar 1. If the state of the world is 0, which is the blue jar, then each person gets the blue tag or blue label with probability p. That's going to be a number bigger than half. And with the remaining probability, the person gets the red tag. If the state is 1, which is the red jar, it's the opposite. The probability of getting the red tag is p. The probability of getting blue tag is 1 minus p. The tag that you get is your own preference. So if you get the blue tag, you prefer alternative blue. If you get the red tag, you prefer alternative red. And if the chosen color by the group matches your own color, then you get the utility of v. Otherwise, you get utility of 0. There are two information treatments. In the no-polls treatment, the only thing agents know is their own color, their own preferred color, the tags that they draw. In the perfect polls treatment, agents know two things. They know their own color, and they also know the color of the jar, the state of the world. So in the perfect polls treatment, I know that it was the blue jar that's chosen, for example, and I got the blue tag or red tag. Voting is going to be costly. Everybody's going to incur the same cost C if they decide to vote. And agents decide whether between one of these three options. They can vote for red, they can vote for blue, or they can abstain. Abstention is free. And we're going to use the simple majority to determine the outcome of the election. It's not very important that we fix the same cost for all agents. You can have the distribution of costs, and everything is translated into the cutoffs under which people decide to vote or not. So that's not a crucial assumption here. So let me go very quickly about the theoretical predictions. So in the no-polls treatment, this is the case in which the only information people have is their own color of the tag. They don't know the state of the world. We're going to focus on the symmetric Bayesian-Nash equilibria. And the first simple observation is that if agents decide to participate, they're going to vote for their own preferred color, because voting is costly. So there is no point in voting for the color you don't like and increasing the probability of this option being selected. It turns out that there exists a unique symmetric Bayesian-Nash equilibria, which has this structure. If costs are too high, nobody's going to participate. If costs are too low, then everybody is going to participate and vote for their preferred alternative. If costs are in the intermediate range, this is between the C lower bar and C upper bar, then there exists a gamma star number between 0 and 1, which is the probability that each agent decides to participate in elections. And the way this gamma star is determined is simply by cost-benefit analysis. You have the cost of C of voting, so you need to equate it to the benefit of voting. Your benefit of voting depends on whether you're pivotal or not. You're pivotal in only two cases. Either you make a tie or you break a tie. In each case, you get the increase in utility of V over 2. V is the benefit from getting your preferred alternative selected. So this expression on the left-hand side of the equation is simply the probability of being pivotal given that there are n number of people and everybody behaves like gamma star. So that's a straightforward implication of the pivotal voter model. And this gamma star is decreasing in the cost in the correlation between preferences P and the number of voters. Okay, what happens when we release some information prior to the elections? So what happens when agents observe not just their own tag, but also the state of the world? In this case, let's focus on the quasi-symmetric equilibria, in which the groups, so if the state is blue, then we're going to specify two voting probability. One for the agents who got the blue tag and one for the red tag. I'm not going to write the formulas, they're a little bit long, but the main result in this case is that there still exists a unique quasi-symmetric base Nash equilibrium, which has the following features. Majority voters are going to participate with the lower probability than minority voters. Elections, because of that, elections are going to be more likely to be toss-up, right? Minority guys voting too much, majority guys lowering their probability of voting. And finally, it turns out that the information that we released before elections is detrimental to the welfare. There are two reasons for that. So first of all, since minority guys participate more and majority less, then majority preferred alternative is selected less often. That's first negative effect. The second effect is the overall turnout. It turns out that if you aggregate the turnout of the whole society, it goes up. Voting is costly, so that's the second detrimental effect. Okay. I'm going to skip this for now. So summarizing all the theory predictions from this model, main things are the following. According to pivotal voter model, voters respond to the probability that they are pivotal, in the sense they're going to vote more when the elections are closer than when the elections are landslide. They're going to vote more when their vote matters, in this sense. And this model gives us several interesting predictions regarding what happens with the release of the information in the form of polls. Information regarding the distribution of preferences in the population is going to induce minority to participate more and have overall detrimental effects on the welfare. Okay, so that's the main predictions of the model, which we're going to now take to the lab and test. Okay, so here's how we designed the experiment. We're going to have three main information treatments. There's going to be no pulse treatment. There's going to be perfect pulse treatment and lab pulse treatment. I'll tell you in a second what lab pulse means. I haven't talked about that yet. So there are groups of 9 people in each election, and the probability of belonging to the majority, this P parameter, is 2/3. So if the state of the world is red, with probability 2/3, you're getting the red tag. If your preferred alternative wins, you get $2. In addition to just playing the game that I described to you in the theoretical part, we're going to ask subjects to do 2 more things. We're going to ask them to predict the group composition, how many you think they're blue and red supporters, and we're going to ask them to predict the election outcome, the vote distribution. All these experiments were done at UCLA in the castle, and we had about 200 subjects. So I'm going to tell you now all the details of the experiment, and please stop me if I'm unclear, because that's important for results. So in each experiment, there are 20 rounds. All subjects are divided into groups of 9, and you stay with the same group for all 20 rounds of the experiment. There's no rematching between rounds. In each period, the computer picks one of the 2 jars, the blue jar or the red jar. In the blue jar, there are 2 blue balls and 1 red ball. In the red jar, it's the opposite, 2 red balls and 1 blue ball. After the state is picked, after the jar is picked, each subject draws a ball from the selected jar with a replacement. So the color of the ball that you draw is your own type. That's your preference. Subjects know that all people in their group draw their types from the same jar, but they don't know the preferences of the other people. At the end of the round, each person decides whether to abstain, vote for blue, and vote for red. And we have two cost treatments. So in 10 periods of the game, the cost of voting was 25 cents. And in 10 periods, it was 50 cents. And the benefit, the payoff, if your preferred alternative wins, is 200 points. So it's $2. The color receiving the majority of votes is the group's choice, and we're going to break ties randomly. Before you make the voting decision, we're going to ask you to predict, to guess the number of red, number of blue tags in your group, and this should sum up to 9, right? Because every person in the group has their preference. And I'm also going to ask people to predict the number of red and blue votes in the group, and this number doesn't necessarily have to sum up to 9, because if you believe that somebody is abstaining, the number of votes, total number of votes, will be lower than 9. The way we incentivize the guesses is we're going to, at the end of the experiment, we're going to pick up one of these guesses at random for each subject, and if you made a correct guess, you're going to get $10. And I'm going to skip the screenshots and just summarize the treatments. So in the no polls treatment, subjects know only their own color, their own tag. They don't know the state of the world. In the perfect polls treatment, subjects know their own type and the color of the jar, the state of the world. And finally, we run one extra session treatment, which we call the lab polls, which aims to mimic what we think real polls look like. So the way it worked is the following. Subjects learn their own type. After this, they are asked to declare their intentions. So they can say, I intend to vote for red, I intend to vote for blue, or I intend to abstain. This is a chip talk. It's not verified. After everybody declared their intentions, we're going to give the group the statistics of this intentions. So we're going to tell them this many subjects indicated they're going to vote for red, this many said that they're going to vote for blue, and this many said they're going to abstain. After this, people actually make their choice, which matters for their payments, and they choose whether to vote or abstain and how to vote. Yeah?
So just to clarify, in this game, the best response for them is to declare that they are going to vote for the opposites.
Okay, so good question. So this treatment, I cannot give you the full characterization of the equilibria in this game. I can tell you something. So if we concentrate on the quasi-symmetric pure strategies equilibria, babbling is always a part of the equilibrium. So you can always construct an equilibrium in which there is no information transmission at the stage. And we should be observing the same things as in the no polls treatments. There is no fully revealing equilibria in this particular case. This is the reason for that. So fully revealing equilibria in the lab polls treatment means that everybody declared their own preference. Everybody declared their own preference in the polls stage. Then we're back to the situation in which there is no uncertainty because we resolved all the uncertainty about the realization of types. And we're back to the Palfrey-Rosenthal game in which we know that for some parameters there exists a multiplicity of equilibria. For the particular parameters in our experiment, no selection of equilibria is consistent with fully revealing equilibria because one of the groups always wants to misrepresent their type to induce more participation from their own supporters. I can't claim that is the case for all other things, but we're still working on it. So at least one thing we know for sure, in the pure strategies, the only equilibria that we should observe is the babbling, no information transmission. There was another question.
It was the same question.
Okay. Yeah, and with respect to the cost treatments, in some sessions we're going to start with the low cost and move to the high cost. In some sessions we're going to start in the opposite direction. There is no significant difference between the behavior in the sessions, so we're going to collapse all the data for the presentation of results. Any other questions about the design? Is it clear what did we do? Okay. Results. I'm going to first talk about the aggregate results, in particular about the prevalence of close elections and about the welfare. Then I'm going to move on to the voting behavior, and I'm going to talk about turnout, response to polls, and the individual analysis. And then I'm going to tell you what people did actually with polls treatment. How do they respond to polls? Okay, yeah. So there's for the simplicity of presentation, I'm going to present the aggregate results between both cost treatments because we didn't find any significant differences. And another thing is we observed very little learning, if at all any, over the rounds, over these 20 periods of the game. So I'm going to look at all periods together. Okay, here is the first result. These pictures show the cumulative distribution of the lead of the winner in each treatment. So there are 3 information treatments. This is supposed to be the red line with the squares. That's the no polls treatment. The smooth black line is the perfect polls treatment, and dashed gray line is the lab polls treatment. And each picture corresponds to 2 cost treatment. The low cost on the left side, the high cost on the right side. Both cost treatments seem to have a very similar picture, so you can just concentrate on one of them. Okay, so what do we plot here? This graph shows us the results of the elections, by how much the winner won, essentially. So if the winner had only 1 vote ahead of the other candidate, then we can say how many of such elections we observed in the lab. So what do we see in this picture? First of all, polls generate less toss-up elections than the no polls treatment. So if you look, if you define loosely toss-up elections as the elections in which candidates had the same number of votes or plus minus 1, the winner get only 1 extra vote, then in the perfect polls treatment, we observe less than 20% of such elections. In the no polls treatment, there are more than 40% of this. The second observation from this graph is that perfect polls and lab polls treatment look very similar. The gray and the black line are very similar. So remember that the theory said that polls should produce more toss-up elections, right? Because minority guys should participate more, majority less, so we should observe more close elections. What we observe here is the evidence against this prediction. Okay, let's look at the welfare. I'm going to look at the 2 measures of welfare. First is the likelihood of selecting the majority preferred alternative. How likely we will select the alternative that is preferred by everybody, by a majority group in this society. And second, the overall utilitarian welfare of the group, which takes into account also the costs that the society incurs. So there is a big table with many numbers. This is the gist from this table. Information or polls lead to better outcomes. In particular, that's mostly pronounced for the very close elections, elections in which the difference between winner and the runner-up is 1 or 3 votes. Information does not raise costs, so overall costs incurred by the society are not bigger when the polls are released than when there are no polls. And information does not reduce welfare. So the overall welfare, when polls are released, is not significantly different from the treatment in which there's no information, no polls. All these 3 things are again against what we predicted from the theory. Because according to the theory, we should have observed the reduction in the welfare that comes from the... Oi, I don't know what I did. Oh, I fixed it. Okay, sorry. The reduction in the welfare should have come from both these sources. First of all, we should have observed higher costs incurred by the society, and the better outcomes should have selected less often. A small note on the welfare equality result. So you can think maybe that the number of observations that we have and for the parameters of the game we set is not enough to be able to even distinguish the difference in the welfare, right? So to show that that's not the case, what we did is we simulated many experiments, the artificial experiments, in which we took exactly the parameters of our game and we made computer subjects use the equilibrium strategies. And then we looked at the difference between the welfare achieved in the post-treatment and no post-treatment. Here's one of the graphs that shows that for the difference between the welfare without information in the no post-treatment and perfect post-treatment. This is the CDF of this welfare difference. If we do this exercise many, many times, then with probability 95%, if people are indeed using the equilibrium strategy, we would have gotten the result according to the theory. That is, this difference should be positive. However, in our experiment, we observe the opposite result. Okay, one more. Yeah?
In the original paper, the welfare goes down. But is it for wasn't the case that it's a special case with two waters, or you get it for any other common entity?
For any.
Okay.
Yeah, that's general. Okay, one more thing about the aggregate result. Let me look at the participation rates of different groups. So one of the main predictions of the theory was that we should observe majority group participating at a lower rates than minority group. In fact, we observe the opposite. Majority groups participate at a higher rate than the minority group. This is the result that other papers have also found. So there is several papers that found the same effect and one paper that found the opposite effect. So, for example, let's look at the cost of 25 cents. In the no post-treatment, we predict, the theory predicts that the probability of participation should be about 61%. We observe in the lab that it's about 55%. When you move to the perfect pulse, when you move to the situation when people know the state of the world, the theory predicts that minority group should participate with probability 1. Everybody should go to vote, while the majority group should participate with probability 70%. In the lab, we observed that majority guys go to the polls with probability 63%, and the probability of voting for minority is 38. So it's the opposite, and that's true for any cost treatment. The same happens with the lab polls. So it seems like polls increase the majority participation and reduce the minority participation. However, if you compare the perfect polls treatment and lab polls treatment, the results again are very similar. Okay, so far I've told you that all the predictions of the theory does not seem to hold in our experiment. In other words, our data shows that we expected to observe more toss-up elections with polls, and we observed more landslide elections. We expected to see the lower welfare levels for the polls treatment, and we observed the same, no reduction in welfare. And we expected the majority group participants to participate at lower rates than minority, and we observed the opposite. So what's going on? To answer this question, we're going to look at the individual behavior, and we're going to use this information regarding the beliefs that subjects hold to understand why and when they decide to vote. So let's start with the most crudest way to inspect the pivotal voter model. And let's look at the elections that people perceive as close and as landslide. It's sort of a kind of a sanity check, right? Yes, sir.
Perceived as close before they get the votes, or after when you release the beliefs before giving the information?
So for the perfect polls, there's no release of the information. Essentially, they just know the state.
In all cases, you ask people first what's their prior.
We ask their guesses, and then we ask them to vote.
Okay, so when you say elicit the beliefs, you mean before they get the information from polls?
So that depends on the treatment. Sorry, that I should have been clearer. In the perfect polls treatment, when the only information they know is the state of the world and their type, we ask them for their guesses, and then they vote. In the lab polls treatment, we ask for their intentions, we release the information, then we ask for the guesses, and then they report. That's right. So it's important the timing of when we do this elicitation. So, for example, in the perfect polls treatment, when people perceive the elections to be as close, they vote with, they participate with probability 59%. But if they believe that the elections are going to be landslides or not so close, they participate at a lower rate. So far, so good. Yeah?
Is that true for both the majority and the minority?
That is, I believe it's the case. I would have to go back and check it. Yeah. In the lab polls treatment, the difference is even bigger. The perceived close elections have the participation rates of 62%. Landslides have 43%. So people indeed vote more when they think that the elections are closer. Yeah.
Are the predictions accurate with respect to whether elections are in fact close, sex close?
Oh, I'll show you the belief accuracy thing. It's pretty close. The elicitation of beliefs shows that people on average get the right prediction.
So what that means is that people predict, using your first set of results, there'll be more landslides, and yet nevertheless.
Yeah, exactly.
Right, so
and I'm going to show you this in this next slide. Yeah.
How much dispersion is there in the beliefs?
So at the beginning, in the first rounds, there's more dispersion than in the end. But all the results that I'm going to show you, that also holds true if you restrict the attention only to the last few rounds in which the beliefs are less dispersed.
But how dispersed?
I don't remember the number. Yeah, on the top of my head, I don't remember this.
I know in some belief elicitations you get a lot of zeros and ones.
No, there is not such a... No. The reports are not very extreme, and as they go along the experiment, they concentrate on more intermediate values. Okay, now, so even though this prediction is consistent with what we would expect for the pivotal voter model, let's look at the elections which are landslides. There are two possible cases. Landslide election could be the one in which your own preferred candidate is winning by a lot, or your own preferred candidate can be losing by a lot. The pivotal voter model will tell us that you should be more likely to vote when you believe that the election is close than in either of these two cases, right? Let's see if that's true. So each of these pictures shows for each information treatment the propensity to vote as a function of your guess about the lead of the preferred alternative. So for example, -3 means that you believe that your guy is going to lose by 3 votes. And then this red bar shows the probability to vote, it's about 20%. The positive number of guess leads means that you believe that your guy is winning. And the gray bars show the frequency of observations, how many of such cases we observe. So the general trend in all treatments, no pulse, perfect pulse, and lab pulse treatment, is that the probability to vote does not go down when you believe that your preferred alternative is very likely to win. The increasing pattern in the probability to vote is contrary to what we would think the pivotal voter model should predict.
So the gray line is the frequency of the guesses?
Of the
outcomes.
Okay, so let me make it a little bit more, do some statistical analysis on that. We can divide all the elections into 3 groups. If you expect the election to be such that your preferred alternative has a big loss, if you expect to be close or expect a big win, then for each of these treatments, we calculate the probability to vote, probability to participate. And as predicted, the left column numbers are always smaller than the right column numbers, and that's statistically significant. So when people believe that elections are close, they're more likely to vote than when they believe that their preferred alternative is going to lose for sure. However, when they believe that their preferred alternative is going to win, almost for sure, or with a high probability, they still go to vote.
Also, by even if they ignore individualistic voting, but in the grouping kind of chances and voting, they would also have a kind of efficiency. I mean, you won't do your job as much as is needed. So it's more like a reciprocal thing, possibly.
Yeah. So this is contrary to the pivotal voter model, clearly. And this is exactly what drives all the results on the aggregate level, because if the majority group participates at a higher rate than minority once the information is released, then we would expect the majority preferred alternative wins more often, which is socially beneficial. We would expect that the elections are going to be mostly landslides with information because majority guys are just go all together to vote. And so all the negative results that I showed you, not negative, the opposite results from the theory that I showed you before can be reconciled given this individual behavior evidence. This is the, going back to the question about belief accuracy. How accurate are their beliefs? The horizontal line, almost horizontal line, this red thing, is the no post-treatment, and that's the connection between the mean guess lead of the preferred alternative and the actual lead of the preferred alternative. The gray and the black one are the perfect pose and lab post-treatment, and here's the diagonal. So if the beliefs are exactly accurate, we should see everything centered around this diagonal. So you can see that in the post-treatment, when some information is released, the beliefs are quite accurate. In the no post-treatment, the fact that for any actual lead of the preferred alternative, people on average predict the win by one of their preferred alternative is consistent with the underlying primitives of the model. So if you compute, given the distribution of types in the population and given the primitives, what should you expect in the elections? You should expect that your guy is winning by approximately one. So beliefs are quite accurate, but people don't best respond necessarily to these beliefs in their voting behavior. How much time do you have?
5 minutes.
Okay, great. Okay, so in terms of the individual analysis, we're going to try to investigate what are the main forces that force people, that make people turn out. So we're going to run the regressions probability regressions to explain the voting behavior with a bunch of other variables. And the main results show that even though we fixed people in the same groups and the same groups played for 20 rounds, there are no group-specific effects in any of the treatments. So you can't, looking at the data, you can't say that one group behaved in a very different way than the other. There's also no time effects, which suggests that there's no learning, and that was the reason that I showed you all the aggregate results together. And the main determinants of the participation are participants go more to vote when costs are low. If you're in the minority, then when majority lead is smaller, that makes sense according to pivotal voter model, right? You have a higher chance of influencing the outcome. But for the majority vote, you vote more when your majority lead is larger. That's this, the additional component that we don't have from the theory that I showed you before. Finally, you go more to vote when the lead of the preferred alternative is smaller in terms of the composition of the group. And there is something like reinforcement learning motive, which says that you're going to vote more today if you voted yesterday and your preferred alternative won. So there's something like you're repeating the same strategies that gave you good outcomes yesterday. I'm going to say a few words about polls. So let's now talk about this lab poll treatment in which we observe how people behave in polls, how do they respond to the information in polls, and how they finally vote. So in terms of the turnout, it looks like polls always most likely to overestimate the turnout. If you look at the polls and calculate the turnout, you're going to get about 82% of voting. In fact, in most of the treatments, the voting was less than 50%. This is the result very well known in the empirical literature in self-reporting surveys, in which people over-report that they're going to participate in elections. Of those who actually report that they're going to participate, only a fraction of them, about 40%, are going to go actually and participate in elections. And there's another group which reports that they're not going to participate, but then after seeing the polls, that they're actually going to vote. Subjects very rarely vote for an alternative different from the one declared. So that's back to the George question. Do people try to induce their own group to participate more by misrepresenting their preferences? Some do, but this fraction is about 6-7%, very small. finally, polls seem to predict quite well the eventual outcome of the election. So in 84% of the elections, polls correctly predict who is going to be the winner. They just overestimate the turnout. Let me show you one more thing about polls, and then I'll conclude. So there is two effects that has been studied and investigated in the literature, both in theoretical and the empirical one: the bandwagon effect and underdog effect. Yes, John.
So I have one other question about that previous slide. When you see this overestimation of turnout, is it mostly or completely explained by being on the losing side? So if you're a minority, small minority, you have a low turnout rate. And so what explains the gap is what I'm asking. Can you account for that?
So yeah, I'm gonna come back to this when I show the bandwagon and underdog effect. Which group essentially stimulated to vote after elections and which after polls are released, and which decides to sit home. So there are two effects that people have thought and investigated in the theoretical and empirical literature before: the bandwagon effect and underdog effect. The bandwagon effect says that the predicted winner in the polls is going to gain an additional support in the actual election. And underdog effect is the opposite. It's the predicted loser in the polls is going to gain additional support in the actual election. So we observe that depending on the lead by the predicted winner in the polls, each of this effect can be dominant. When the predicted lead in the lab polls is rather small, so when people predict that their preferred, the polls predict that the preferred alternative wins by 1 or 2 votes, then it's the bandwagon effect that dominates the other one. And when the predicted lead is higher, it's the underdog that wins. Now, this picture is consistent with what individual behavior that we saw in the previous slides. So, for example, bandwagon effect is precisely the fact that when you see that your preferred alternative wins by 1 or 2 votes, instead of decreasing your probability of voting, you increase it, right? That's the majority voting more, majority voting when they believe that their preferred alternative is winning. The underdog effect is the effect of this few small fraction of population that misrepresent their preferences. It's the minority guys that in the polls they said that they prefer the other alternative, try to induce their group to participate more, but then when actual election comes, they vote for their own alternative. So let me summarize. We were interested in studying the effects of the information in the form of the pre-election polls and beliefs on the probability of voters to participate. To do that, we conducted the array of experiments trying to inspect this behavior in the lab. In terms of the outcomes, we see that polls have very weak, if any, effects on the welfare. Polls yield more landslide elections and not the toss-ups. And we observe bandwagon effects for small victory margins and underdog effect for the large victory margins. In terms of the individual behavior, which is the direct test of the rational voter model, we observe that, consistent with this model, people participate at higher rates when the closeness is predicted, but there is a propensity the propensity to vote increases with the guess and belief that your preferred alternative is going to win. And in terms of the polls behavior, polls accurately or pretty accurately predict who is going to be the winner of the election, but they overestimate the turnout. Any questions? Okay, thank you.